This differential equation can be solved for c since we're given some initial condition. So when we're solving differential equations, the main idea is that we separate the variables and we integrate. So I'm going to separate my dy with my y. The coefficient, the constants don't matter where you put them. And I'm going to put my x's with dx. And I want to put the cosine into the numerator because that cosine in the numerator becomes secant squared, which I can anti-differentiate fairly easily. So there's my first step. I'm going to separate, integrate. I'm going to integrate this with respect to y, so that becomes log, sorry, it's going to be the integral of log of 1 over x, which is log y. Okay, and I'm going to avoid the plus c right now. I'm just going to put the plus c on the second term. So this is going to be the integral of secant squared. So that's going to become tan x. And then I'm going to put the plus c here. Okay, now at this point I've anti-differentiated this. I can substitute in x and y to work out my constant value. I can solve for y as well, but I'm going to just solve for my plus c first. So I'm going to substitute in my values of x and y. So log y is going to be log 5. X is going to be 0, so tan 0 plus c. So then this works out to be the square root log square root 5. That's going to be 0, so that's going to be my plus c. Okay, so there's my plus c. I'm going to then rewrite this equation in terms of y equals. So solving for y, I'm going to maybe put the y, rewrite it like this, log y to the power 1/2, or square root y, is equal to tan x plus log root 5. So that's my first step. I'm going to then solve for y. Y equals, so y to the 1/2 equals e to the power tan x plus log root 5. Now, because this is going to end up being a coefficient, I'll show you how that looks like. This is e to the tan x, and this is times e to the log root 5. And then I can just use my identity to make that equal to root 5, and that becomes the coefficient on that e function. So y to the 1/2 is equal to, this is going to be root 5 as my coefficient, e tan x. Okay, so it looks much cleaner than leaving that log root 5 in the exponent. And then squaring both sides, I end up with 5 e to the 2 tan x. Okay, so there it is. There's my function. I've solved for my constant value, and this represents the solution to that differential equation that happens to pass through 0 and 5.